All right, stats students, we're going to be talking about experiments today. Now, experiments are a very rich topic, a lot of new vocab in here, so we're just going to kind of touch the surface in this video, and then we're going to delve a little bit deeper in the next one. Now, we've been talking about samples a little bit. Now, a sample essentially, or a survey, right? You're observing something going on, right? So let's see. We're going to just get this out of the way. We're going to start out with this because it's important to know what this is before we jump into an experiment. So like if you're doing a sample, right, or a survey, a sample survey we'll call it, right? An observational study. What you're doing is you're observing. You're seeing stuff happen and you're taking down what you notice. You're not influencing anything. I'm going to put observing. We're going to say you keep track of what you notice. And you don't influence anything necessarily. No attempt to influence. At least if you're doing it well. We talked about that. So you're not really attempting to influence anything here. Now with an experiment, it's a little bit different. Now an experiment, what you're doing is you are imposing a treatment on somebody or something. So you're imposing a treatment and then you're seeing what the result's going to be. Experiment, you are imposing a treatment. And ultimately, you're looking to see some sort of response. Some treatment to see a response. Now, you have two types of variables when it comes to this. You have a response and an explanatory variable. So for an explanatory variable, that's what you're hoping is going to explain what happens, right? Explanatory variable. Leads to something happening, right? It leads to something happening, explains how it happens. Explains, leads to your result. That's a good way of putting it. It explains or it leads to your result. You're influencing it. It's what's influencing that, right? Influencing. Now, then you got your response, right? Your response variable. You measure this to see if your explanatory variable, I'm just going to, explanatory variable, affected your response. And I got an example that we're going to use throughout this, right? Now, let's say I go down to the track, right? And I think someone comes to my head. And I said, I want to see if a Big Mac will make someone run faster. If they eat a Big Mac, if that's going to make them a better runner. So here's what we're going to use, right? We're going to do an experiment. Do Big Macs make you faster? So let's try what we got here for our explanatory and response variables. And let's also take a look at our treatment, right? Because we're imposing a treatment. What's our treatment going to be? We're going to make our subjects eat Big Macs. Eating Big Macs. Now, subjects, those are people who are participating in your experiment. Now, if it's like an object, we call them experimental units. But since we're doing an experiment on people, we're going to call it subjects, right? So the treatment we're going to impose is we're going to make some of them eat Big Macs, some of them aren't going to eat Big Macs. Well, we're going to talk about that a little bit, but we'll randomly say half of them eat Big Macs, half of them don't, and then we're going to have them run around the track and see who's faster, the people who eat Big Macs or the people who don't. Let's see. So we will say our explanatory variable is Big Mac consumption. And our response, how are we going to tell if our Big Mac works? Well, we're going to see running time. Now, there are a lot of different ways we could do this. We could have everyone run around the track and then have people eat Big Macs, and then everyone runs around the track again. We can see if the Big Macs actually make a person run faster. We could just have people eat Big Macs, have them run around the track, have some people not eat Big Macs, have them run around the track, see if we notice a difference. We're going to talk about how we can set this experiment up to see how it works. But ultimately, our explanatory variable is Big Mac consumption. We are trying to see if Big Mac consumption can affect running time. And our response, running time. We're going to see if Big Mac consumption can lead to a difference in running time. Ultimately, I want to prove that it makes you run faster. Now, we shall see. So this is the basic, what you'd start an experiment with. The basic terms, right? You got your treatment, you've got your explanatory variable, and you've got your response variable. Now, if it were an observational study, right, that would just be me hanging out on the bleachers, right, watching some people who are about to run, and I notice, those kids ate Big Macs and those didn't. The kids who ate Big Macs seem to run a little bit faster. So you might want to jump to the conclusion, hey, Big Macs might make them run faster. But you can't do that because it's an observational study. You haven't imposed any treatment. One, you can't make them run. Two, you can't make them eat Big Macs. You can, say like, I noticed that those who ate Big Macs ran faster, but you can't come to the conclusion that Big Macs are what made them run faster. That's what you're hoping to do with an experiment. You're hoping to say that this treatment leads to this result. And we're going to talk a bit how you can do that. All right. So one way you can do that is you design an experiment, right? And I'm not going to say this is going to necessarily be a good experiment, okay? We're having a little bit of fun with this. But one way you can design an experiment is using something called blocking, right? So what you do is you just break down your steps and then ultimately you track your results. So let's say I started out with 20 runners. Whoops, not runners, runners. Okay, so I start with 20 runners, right? And now, as we know, when it comes to statistics, random is good. So what I'm going to do is I'm going to use random assignment. Now notice I'm not saying random sampling. There's a big difference here. In experiments, you do random assignment. In sampling, you do random selection or random sampling. You don't do sampling in an experiment. Vocabulary is key here. So I'm going to use random assignment, right? And say I use a random number generator, right? Assign everyone number 1 through 20, randomly select 10 to go here, and then 10 to go here. So I'm off to a start. All right, I've split everybody up. Now, I've got a couple of treatments I'm going to impose here. Top here, I'm going to make them eat Big Macs. And if they say, well, I don't want to, well, guess what? They volunteer for this experiment. They have to eat Big Macs. That's part of the deal. They eat Big Macs. The people down here don't eat Big Macs. Now, you notice how I'm breaking everything down here, right? The thing with when you're doing a block design is you're accounting for variables and you're accounting for random assignment. It's a nice, easy way to be able to analyze your experiment after the fact and be able to see where these results come from. All right, so I've assigned 10 to eat Big Macs, 10 to not eat Big Macs. All right. So I'm going to make them run. Run. They're both going to run. And, maybe have them run around the track once or twice. Now, I could, and that's something you probably want to keep track of here. I think I'll do that. Run, track. I'll put run the track. They do the same thing. Now, if I want to get into more details, I can say whether I have them do it at the same time or whether I have them wait, like maybe the people who don't eat run first and then the people who eat run second. That's something you can get a bit more detail into if you want. So then, let's see. 10, they eat Big Macs, they run the track. We can record their times. Record time. We're going to do that for both here. And then we compare. And that's at the end here. Now, you're going to say, you did not design a very good experiment, Mr. Gamache. I know I didn't. because there's a lot of stuff that can come into play here. And that's one of the reasons I did this, so that way we can talk about this. Now, there are a lot of things I did not account for. And let's say this happens, right? Everyone runs around the track. I notice, the people who ate Big Macs ran faster than the people who didn't eat Big Macs. I'm going to say that Big Macs make you a better runner. Now, chances are you're hearing this, you're saying, there's a lot that could come into play, Mr. Gamache. You're absolutely right. There are things that could affect these results, right? That these things will affect my conclusion. Not only going to affect my results, they're going to affect my conclusion, because I can't definitively say that Big Macs are what made these people run faster. There could be a lot of things. Maybe the people who ate Big Macs, maybe I just happened to randomly pick people who are really good athletes, and the people who didn't eat the Big Macs, I happened to randomly select people who never run. Maybe they're couch potatoes. I don't know. Maybe I happen to pick all these athletes here. I didn't pick athletes here. Or maybe it could be the other way around. Maybe I say, hey, maybe, not eating Big Macs makes you a better runner. But there's no way to definitively say that. There could be a lot of factors in play. Maybe the people here are taller. Maybe the people here are shorter. There's so much you want to account for. And what we're talking about here are what are called confounding variables. And what confounding variables are they are variables that affect your conclusion. To affect your conclusion, so you don't know which variable led to your result. And there are a lot of ways you can account for these. Like if I wanted to block a bit further, and you can see block designs can get pretty intense. I'm going to take a look at my block design here, right? So I'm going to take a look. And what I could do instead, right, is I randomly assign 10, randomly assign 10. Maybe what I do here is, let's see, before I do that, I'm going to shrink this down. I could account for the variable of athletic ability. Maybe that's a variable. I mean, if they're already good athletes going in, maybe it's not really going to affect their time so much. So a variable I'm going to account for here is athletes and non-athletes. So you notice I'm going to break up every group into athletes and non-athletes. And what that allows me to do, right? And excuse the crudity of this. You're going to notice that these can get a little crude and they can get a little messy. But by doing this, right, then I can check in each category, right? So maybe for the Big Macs, right here, I have the athletes and the non-athletes. Maybe I have it here too. Or maybe, it might be a better idea. I'm glad I'm doing this. We can put this at the beginning instead, right? That way we can have different groups eating the Big Macs and not eating the Big Macs. Because then you might notice, hey, maybe if you're not an athlete, it does help you run faster, but if you are, it's not. So here's what we can do here, right? Before I even randomly assign these 10, right, before I randomly split them up, I'll do it to athletes and non-athletes. I'll just split them up, put them in their own groups. Non, right? And then from there, I can do this separately in each little subgroup here. So I'm going to do this. Gotta love copying and pasting. I'm going to do this for every group now. And that allows me to kind of isolate things. That's what your goal is. You want to isolate these variables. Now this looks a little messy, but bear with me. So I took the athletes and the non-athletes, and then I split them up. So let's say we have 40 people now. You can change your numbers up. Now again, this is all in theory. I mean, ultimately it's a little different if you're actually putting this into play. But all right, so I took 40 runners, right? Separated them into athletes and non-athletes. And then within those groups, I split them up. So half of the athletes ate Big Macs, half of them didn't. Half of the non-athletes ate Big Macs, half of the non-athletes didn't. And then each of these groups run the track, record times, and then compare. And then maybe I notice here, among the athletes, those who ate Big Macs did run faster. But when it came to the non-athletes, those who ate Big Macs did not run faster. So then you might be able to come to a conclusion, maybe Big Macs just work for athletes and maybe they don't work for non-athletes. Or maybe you'll notice that, in each group, those who didn't eat Big Macs, they ran faster. Now, in that case, you can come to a stronger conclusion that not eating Big Macs makes you a faster runner because guess what? We separate the athletes from the non-athletes. We know that's no longer in play. We don't have to worry about that. That's the cool thing about block design. What you do is you account for all these variables. You could even go even further. I could do it by height or age here. I could go by athletes and non-athletes. Then I could split by age and then separate it. So the goal with this is you're isolating all these confounding variables that could possibly affect your conclusion. So that way when you get to a conclusion, you can't say, well, it might have been this that affected these results. Because if you account for them in this block design, then ultimately the variable that you were hoping, your explanatory variable, the variable that you were looking to see if it affects that response, you have a better chance of seeing that it affects your response as opposed to something else you didn't plan for. Now, another way you can deal with an experiment, right, is called completely randomized design. I like this, randomized design. A lot of people like this method because it's a little bit easier than block design. Actually, it's a lot easier. What's a completely randomized design? What you do is you don't even account for any of the variables. You just completely assign treatment and then you just let it go, right? So don't account for confounding variables. And what you do is randomly assign treatment. Now, say, like what would look like in this case, right? Say we had like 40 people. Instead of blocking, I just randomly take these 40 people, give half of them Big Macs, half of them I don't give Big Macs, and I see how they run. And now you might be saying, but what about all these other things that come into play? What you hope with a completely randomized design, right? What you're hoping is that you have enough people on each end. Like say I did that, right? I randomly assigned 20 people and 20 people, right? Big Macs, no Big Macs. So then what you're hoping is that when you look at your results, since you did random assignment, you have enough athletes in each category that whatever results that being an athlete would impact ultimately get canceled out. Hopefully you think that maybe I get enough tall people in each category so that any effect that the height would have on your results will cancel out too. That's the cool thing about completely randomized design. You're hoping that by doing that, you're spreading out all these confounding variables so that they're on each end and that any effect they would have on your ultimate results are going to cancel out. So that's the beginning of experiments here. We're going to talk a bit more about it in the next video. We're going to throw some more terms at you. But ultimately, the things I want you to pull from this are, with an experiment, you're imposing a treatment. As opposed to an observational study, where you're just kind of watching, you're just seeing what happens. With an experiment, you're actually imposing treatment. And you're trying to see if that treatment is going to affect your results. And you want to watch out for confounding variables. Those are the variables that you're hoping that when you see your results, that they weren't the things that affected your results, as opposed to what you were hoping would affect your results. Again, like as I said with the Big Macs, I'm hoping the Big Macs affect my results, not confounding variables like age or height or athletic ability. Those would be confounding variables. So those are the key terms here. We're going to talk a bit more about experiments in the next video. It's a very rich topic. Hopefully you pulled something out of this video. And again, you're going to be seeing more of it, and I'm going to present more in your next video.